Hello, and welcome to Lesson 8, which is ROV and AUV ops and deep water operations. Remotely operated vehicles, or ROVs, and autonomous underwater vehicles, or AUVs. And here are pictures. We've got an ROV on the left and an AUV on the right. Now, we're going to talk in greater detail about these different kinds of search devices in just here in a minute. A remotely operated vehicle is one that is controlled by an operator that's not actually on the vehicle itself. They're always tethered to usually some type of search platform like a boat or other type of maritime vessel. There are cables connected to it. And the ROVs use cameras and other different kinds of sensors. Many have sonars on it. Sometimes there's magnetometers, although those aren't too often found out in the real world. But they range from the great big ones that you see on the top to the very small ones that we use at Mass to find shipwrecks in much shallower waters. Now, in deep water, you really need to have a tow sled, especially when you have an ROV that's very big, maybe the size of a Volkswagen Beetle. But the tow sled is used to take the ship-induced motion disturbances away from the tow line. So what happens, you can see in the middle picture there, the tow sled is operating and it's got a neutrally buoyant cable so that the cable doesn't sag down and get caught on things or get tied in a knot. And the tow sled takes up all the pressure of the tow vessel, dragging it through the water. So that's where you need that tow sled. And the tow sled usually has a camera and lights on it so that they can see the ROV down below it. It's a really complicated system, very expensive, and places like Woods Hole Oceanographic Institute use these all the time, but they're not something that small organizations use quite a bit. And you can see there's the ROV on the bottom picture and the giant winch they have just to put the tow sled and the ROV in the water. Definitely something you need a big boat for. And then autonomously operated underwater vehicles are a different kind of search system. They're programmable robotic vehicles that you basically chuck over the side and it runs out in a guided path, and it uses video, many different types of sonar. Talked about side scan and multi-beam sonar in the past, and some have magnetometers as well. And you can see there's all different varieties of AUV on the images that we've got below. The big one, the great big one, is a deep water one that the guys searching the ocean for lost ocean liners will use. The one in the middle is kind of an operated. The yellow one is kind of a middle of the road version that system or people like NOAA and other people that are searching large areas that have a lot of money, they'll have one of those kind of vehicles. The small orange one down at the bottom is one that we've actually used at Mass. It's about 4 feet long, and it's about maybe 8 inches in diameter, and it can put side scan sonar on those, and they can in the bottom see where you can have an autonomous vehicle towing a magnetometer. So you want the magnetometer to be a good distance away from the AUV, because you don't want the magnetic field generated by the metal on the AUV to be messing with the magnetometer readings. Now, there is one type of vehicle, and that's the light AUV, which incorporates all of those types of sensors in one platform. It's very cost effective because you don't need a ship out there or a boat. So for what it costs you for a day for a ship or a boat, you can probably pay for this whole thing, or maybe a couple of days worth of boat time. But it's the sensors on bigger vessels are towed so that they have issues with maintaining depth above the bottom. And this one has it's kind of a direct system that has both the side scan, you can see that in the back, a camera on the bottom, and a magnetometer up front. Now, this magnetometer has been magnetically isolated from the rest of the AUV. So they don't have to worry about towing this thing behind it. It's actually incorporated into the underwater or the autonomous underwater vehicle. So it's great that they're all together. It is cheaper than having to rent a boat for many days, but it's really much, much more expensive than having a separate magnetometer and a separate, say, side scan on an AUV. But the prices are coming down, and as I'm talking now, I'm sure it's less than it was when I started this presentation. So like I said, the self-compensated magnetometer is capable of being carried on the vehicle. And it's, like I said, less expensive than towing an AUV or towing an ROV at different places. So the different kinds of navigation for AUVs, most have some kind of an INU in it, which is a inertial navigation system that uses accelerometers and gyros to measure the vehicle's movement in 3 directions, left, right, up and down, all of those kinds of movements. And then it generates really the best estimate. And if you have a super high quality, high expense AUV, you're going to know pretty much where you are most of the time. If you have an AUV that doesn't have all the best accelerometers and gyros, you will know kind of where you are. Hopefully you'll know not to hit the bottom or to run into a seamount or something like that. But again, it depends on what you pay for is what you get. But the inertial navigation unit will keep the AUV in the space you want it to go. They usually have a sonar depth finder. If you look at the bottom picture, that little orange cone down at the bottom is the sonar bouncing off the seafloor, tells you how far you are above the bottom of the ocean. And then some of the best ones have a collision avoidance system, which is somewhat like a side scan sonar, but in the vertical range, that will look ahead and see if there's anything that the AUV is going to run into. And then it's the program on the machine is developed to turn one way or another to avoid any obstruction in the water. There are a number of different communication systems that AUVs operate with. One, again, you have to have a tow ship for this, or if you're doing something nearby, you could probably figure out a way to do it from the shore, but it enables the ship operators to send and receive data to the AUV while it's operating out in the water. It's acoustic. It uses Morse code as a method, and you could type it in and it'll convert it to Morse code and send that directly to the AUV. It says, don't search here, search in another area. Usually have plans developed for that, plan A, plan B, plan C. You might want to do plan A and then, decide that plan C is more important than B, and you can have it execute that. And most importantly, you can find it and tell it to come home. Or if it has an issue, it can talk back to you and say, I'm having an issue and I'm surfacing, and when I get on the surface, I'll talk to you. And the way they can talk to other places is with a a three-way antenna that uses GPS, Iridium, which is a satellite cell phone, and a Wi-Fi system. So you could be out there and your AUV might be in the deep ocean, you're working for NOAA, and this thing pops up. It's going to get its GPS location. It's going to call up Iridium, which is a very expensive phone call, and it's going to send a phone message directly to the tow ship or back to shore saying, here I am, I'm doing fine, I'm going back down. And if you're close enough, if your tow ship is nearby or you're operating very near some place that you can have your Wi-Fi set up, it can dial into a Wi-Fi network and pass you all kinds of data by doing that. So two methods are acoustic modem transducer and the three-way antenna for GPS, satellite phone, and Wi-Fi. And there's another type of AUV that's operating, and this is brand new. I just checked, and they're still working on it, but it's a soccer ball size spherical AUV. And you can see pictures of it in the tank on the bottom. And this thing is designed to penetrate and investigate the interior of shipwrecks. So it can go through small openings and then move around inside if there's enough room to do that. And divers have done that for years, but now they've got an AUV that can actually go inside there, and it's programmed to look at different walls and make different turns. The one thing they haven't really gotten squared away yet that I could find is that they don't have lighting for the cameras. And if you've ever dove on a shipwreck, once you go inside, you can't see anything for the most part. So they're working on that, but I hope they're going to have this system operating. And it's kind of a garage project. So hopefully it won't be terribly expensive. Of course, some company might pick that up and manufacture it and charge an arm and a leg for it, but we'll see. Okay, deep water archaeology or archaeological oceanography, I'm sorry, was kind of developed by Dr. Robert Ballard. He was a marine geologist working for Woods Hole Oceanographic Institute. In 1977, he was studying geothermal vents in the Atlantic Ridge. And you can see the vehicle down there on the very bottom is called Angus, and that was the very first remotely operated vehicle. It just by itself, and it just had a camera on it, very big, and they moved it around by towing the boat. There was very little movement of the ROV itself, but it was able to get down to 8,000 feet and look at these geothermal vents in the Atlantic Ridge. And they were able to find out that these were chemosynthetic life forms that lived down there. They did not rely on sun with the photosynthesis, and there were shrimps and other fish and algae that were down there that did not ever see the sun and lived a very happy life. So they're believing that this was probably how life formed on Earth when it was a water planet. There were life forms that used the chemicals from the black flumes and gave life to the planet. And then eventually they moved out into the land and used photosynthesis. Very important discovery for Dr. Ballard. So Dr. Ballard, while he was a geologist, underwater geologist, he really loved underwater archaeology, and he's pretty much known for a lot of his discoveries. He was also a U.S. Navy commander in the submarine corps. And in 1985, he was working for the Navy to find 2 submarines. And there's a movie and you can find it on YouTube. It's called Titanic Ballard's Secret Mission. And he went looking for the USS Thresher, which was lost off the east coast of the United States. And sunk in very, very deep water. So he ran his Angus ROV down there and took a look. And what he discovered was that the Thresher had a debris field that was a mile long. So rather than just using his camera and sailing back and forth and back and forth and back and forth and back and forth, trying to find the wreck site, he discovered that as the submarine sank, pieces of it would fall off. As you see in the drawing down here, the stern falls off, the bow falls off, and then the middle section hits the bottom. And that debris field is a very long way, a mile long, as opposed to a 300-foot submarine. So he took that. He did find the Thresher. He took lots of videos for the Navy. Many of them are probably classified still. But he took that theory and he looked for the USS Scorpion, which was another submarine that was lost just west of the Straits of Gibraltar. And he found that at very deep water. And he found it very quickly because he searched for the debris field rather than the actual submarine. Now, once he did that, he found out that he had time. And he asked, because he found it so quickly, he said, "Hey, Navy, how about letting me go look for something else real quick?" And they said, "Sure," because they were so happy with what he had done. And he went up north into the Atlantic and searched for the debris field of the Titanic and found it in a few days. So it was really very fortunate that the idea of him looking for these submarines for the Navy allowed him to use that same technology of looking for the debris field to find the Titanic. And, we get movies and all of that stuff out of his discovery. Wonderful, wonderful job with the Titanic. So Robert Ballard, he took all of these wonderful things he did in the 1980s, and he developed the Archaeological Oceanography program at the University of Rhode Island, URI. And they've got a great master's and PhD program, but you really have to be an oceanographer to be in it. But then they will teach you shipwreck stuff. Very interesting, though. He wrote a great book. It's a little dated right now, but it talks about all the things that he's done searching for different wrecks throughout the world. And he developed the Inner Space Center at URI. Now, you heard about outer space and a lot of outer space vehicles and things like that. And he said, well, let's look at inner space, the inner space on the planet that we know almost nothing about, which is the bottom of the ocean. So Robert Ballard's expeditions in the meantime, while he was setting up URI programs, were the Titanic that everybody knows about, the German battleship Bismarck, which he found, and the USS Yorktown, which was lost in the Pacific during the Battle of Midway. Now, you see these wonderful images down there. The photographs are actual images. That's the one on the right is the Yorktown, and the one on the left is Bismarck. But you will never see the entire ship down there because they're down so deep, there is no light. It's not like they're in a swimming pool and you can see light coming down from the surface. So there's no light. So what they had to do was go slowly around the vehicle and record everything and have either computer models or artists generate these types of views. Very interesting and very amazing looking. Okay, so the Inner Space Center, very, very interesting stuff. Down at the bottom, innerspacecenter.org. If you're really into this stuff, I would call it up and spend some time listening to what they do. They're not always out, and they're in kind of weird time zones because they're all over the world, whether in the Pacific or out in the Mediterranean or out in the deep Atlantic. They're doing many, many missions all at one time. But they'll do oceanography, marine biology, geology, and of course, maritime archaeology. So they'll go out and they'll look for certain things, and when they're there, they'll have scientists on board, and they'll try to extrapolate all the information from all of those different areas. And I used to listen to this when I was going through school, and I'd be sitting there working on my, homework from school, and I'd have the Inner Space Center up in my speaker system. And these guys would be cruising along, and you hear them talking about, oh, that's a cool geographic ridge, or hey, that's an interesting looking squid or something. And then every once in a while you go, hey, what's that? And they probably found a shipwreck when you hear that. They would search a deep water geological event or place. And then instead of recalling this ROV thousands and thousands of feet, they would just raise it up high enough to keep it above the seamounts. And then they'd chug at 2 or 3 knots to their next target. Well, as they were doing that, they were looking down, and especially in the Mediterranean, every once in a while you hear them go, hey, what's that? And it's always some ancient shipwreck. So very interesting stuff. They do have a lot of citizen scientists participate in this, and this is a great way to do deep water archaeological oceanography and never have to get on a boat. You don't have to worry about seasickness or leaving home. You can dial in from your computer at home. Very cool stuff. Okay, some of the other deep water oceanography that we have. We talked about ROVs and AUVs. We've got now a hybrid of that. Saab is producing the Sabertooth combined hybrid AUV ROV, and it's pretty cool system. It has 3 different modes. Autonomous mode is where they program it in and say, go search this area, and they kick it off just like a regular AUV. These are really important for people who are constantly searching for pipeline integrity, particularly in the oil fields in the Gulf of Mexico. So they'll say, go find this pipeline and go look for it and check it out and record all your video. And then the operationally assisted version of this is where they basically have a tether, but they let it do its autonomous mode, but they occasionally give it new orders. It's kind of like what we talked about with the with the AUV and the sonar system between the ship. They don't use sonar. They usually have an attached cable, but it basically lets it run its course, and then you do fine adjustments when you need it. And then there's a manual adjustment where it's got a cable on it and it just operates like any other AUV, but it does not have the tow sled and the deep water capability for long range searches. Again, it's mostly for looking for particular things in particular places. And this vehicle was used to find Shackleton's ship, the Endurance, down in the Arctic. And here's some awesome pictures of what this little combined AUV ROV could get out of water that's crystal clear down many, many thousands of feet. So deep water archaeological oceanography is making further and further advances all the time as technology improves. Okay, so let's talk about deep water excavation. Rarely done anymore. Archaeologists don't want to excavate an entire wreck anymore. They want to keep it in situ, keep it intact for future archaeological work. Remember, one of the things you do is when you pull apart a wreck, you're destroying that wreck for other people to look at. So if you can answer your question without doing any excavation, you want to do that and keep the rest down there for somebody else who might want to study the arrangement of things, who would best be served having the wreck in front of them instead of what you recorded. So we don't want to do that anymore, but they have done it in a while, particularly in the early 2000s. It's very complex and very costly. That's another reason why a lot of folks and a lot of organizations are not doing this, because it just takes a huge ton of money. Now, we can go down there and retrieve diagnostic artifacts, which might tell the archaeologist what the ship is or what the ship did, or answer particular questions. So you can go out and pick up a certain thing and recover it, but we're not really doing excavations of the entire wreck anymore. So we want to map it and photo it and take it home and study it that way. And even from 2002 to now, that's a much, the technology is greatly improved to where you can do a lot more with photos and photogrammetry and different kinds of mapping technologies that you didn't have back in the early 2000s. So what they did do, and if you ever want to do get involved in any kind of deep water excavation, even if it's just for a diagnostic artifact, you want to have really fine control of the excavation process. There were times where certain treasure hunters would go out and they'd have a vent system where they would anchor the boat, turn this vent down to where the screws would just blow all the sand away from the wreck. And that was easy to get to the treasure, but you really couldn't learn a whole lot from that type of excavation. So we do fine controlled excavation. We document the process the entire way. So like I said, it's a destructive endeavor, and we want to have safe retrieval of the artifacts and samples. And remember, these things vary in size widely. Some are very small, some are very big, they have different weights, and they're all in different states of preservation. Some ceramics might be very well preserved. Wood might be, as soon as you pick it up, it disintegrates. So you have to keep all of those kinds of things in mind, and that's in any excavation underwater. But deep water excavation, you don't want to spend millions and millions of dollars to go out there and, come back with nothing because you didn't plan for the preservation of your artifacts. Okay, we talked about the manipulator. I mean, talked about the precise excavation system that we have, and the manipulator arms on the ROV are very important. They're getting better and better all the time, but they need to do very fine grained things like picking up things and moving them. They need to be able to swivel and turn. And like I said, it's getting better and better all the time. Now there are you almost always have to have some kind of an elevator system, because you don't want to pick something up, particularly if it's one of many that you're researching, and then drive all the way up to the surface, drop that off, and then drive all the way down. It takes sometimes hours to get down to the depths that you're looking for. So you have some kind of an elevator system where you can go over, pick up the artifact, move it over to the elevator, put several artifacts onto the elevator, and then send it to the surface. It's usually got a bunch of weights on the bottom that they release, and the thing glides up to the surface, and another one is dropped down. Really, when you're down there and you're trying to save time, elevators are the thing you need to have for sure. There are also tube cores, and these are clear polycarbonate tubes. They send that entire tray down to the bottom, and then they punch these tubes into the bottom of the ocean, and they pull up different sediment, and they've got vents in the top so the water can flow out, and then the mud and the sand and all of that can go up into the tube. Now, if the sediment is finely grained, you can build some kind of stratigraphy in there, but a lot of times you get down there and mud is just mud. It's just, and sand is just sand all the way through. But what they are using this for, and they're still using this today, is they're looking for the deep water settlements out on the continental shelf for Native Americans that were living in that area during the last ice age when the sea levels were much lower. So they go down to an area where they think is a place where they might find some Native American artifacts underwater, under 200 to 300 feet. They drop this down and they core and they pull it up and they hope to get. And I don't know that they've found anything so far, but they're still working on it. They're hoping to find arrowheads and pottery and other things that would show, yes, there were people living in this area while the water levels were very low. And if they get the right artifacts, they might be able to trace who they were and when they were. Very, very interesting capability for tube cores in deep water. Now, the ROVs can use, besides just picking things up, they use a water jet and a suction tool. So you can see down at the bottom, the water jet is the very thin needle-looking thing at the bottom. And then the suction core, the jet actually goes into the core and it blows with the jet, and then it sucks it back in so that you don't have this big cloud of debris in the water as you're doing your excavation. And it's back flushed so that if it gets clogged up, you can always get most of that mud and sand out of there. So it's a very intricate system. You don't want to be just blowing stuff out, and you don't want to be just sucking things straight out either, because that makes it hard to identify sometimes. And the super high tech, paintbrush on a stick is also an option. Basically, they've used a lot of diver tools that they put on the end of a stick used for the ROV. And then they've actually configured several different cool devices for picking up specific things. An amphora, remember, those are the containers that they use to carry things around in wooden ships back in the Bronze Age and the Byzantine empire and those kinds of things. Well, those are a certain size and a certain shape, and they've developed arms that can pick up certain types of amphora easily and not have them worry about being crushed or dented or scratched too much when they're being excavated. So amphora lifter is one that they still use that just to find individual artifacts, not for an entire excavation. And then there's the standard kind of things that ROVs use all around the world, and those are clamshells and grippers and all kinds of things that are currently out there for everyone to be that everyone can use besides archaeologists. Okay, we talked about conservation and how important it is. A conservation officer or conservator has to be part of your team. It has to be budgeted from the beginning. You can't just go down there and pull up a bunch of things, dump them on the back of the boat in saltwater buckets and carry them back. Not when you're talking about deep water conservation, when you're excavating an entire site. So you've got limited space on every boat or ship. As soon as you get a big enough ship for what you think you need, you're going to need more space. So you're solving the problem of keeping all of these artifacts is a big thing for the conservator to deal with. How do I use the limited space that I have, and how can I be fairly ingenious as far as stacking things go to make me able to collect everything I need and keep it preserved until I get back home? You could be out there for weeks doing this, and then it might take several more days to get home. So you've got to be able to conserve this stuff, and you've got to be able to lift it. You got to be able to label it, record it, because if you just bring junk up off the bottom, that doesn't help. I need to know where you got it, when you got it, who got it, what other documentation do you need for it, and then you need to pack it properly, and then you store it. And then in some cases, you can, if you have enough room, you can start desalinating these artifacts even while you're out at sea, because that will not only help you in the conservation process overall, but it may be the only way you can preserve these artifacts in the amount of time it takes to get back to port. Now, like I said, there are not very many deep water excavations going on right now. But one of the best is the Mardi Gras wreck the Texas A&M did in was discovered in 2002. Texas A&M did an excavation of it in 2007. And if you go down to nautilusproductions.com on YouTube, you can see, I think there's 7 or 8 videos, small videos, that show exactly how this entire process took place, how they excavated things, how they conserved them, and all of that. And these are also, you can have links to these in the Canvas for the course. Will take you right to these as well. Okay, that's it. Deep water excavation and archaeology. If you have any questions, send me an email and I'll be happy to answer them for you.